Now in computer, the integration is implemented in computer programming. There are advanced level of programming that is there to implement integration, and more advanced fast method of integration is coming. So maybe our students will be able to create this new knowledge of integration in a different way, provided they understand, apply, analyze, evaluate, and then only they can create. So our job would be to see that the students are able to do that. So with this background, let me talk about CSIR virtual laboratory for school students, that the concept that we have in our mind, which might be having a lot of errors because we are not interacting with students. Therefore, we need your help, your suggestion, how we can make something really useful, interactive, and effective. So, what is the background of this virtual lab? But I understand that you have heard about CSIR, Council of Scientific Industrial Research. We are involved in R&D, and there are 39 labs in various places in India. Jamshedpur is one of the labs which is working in metallurgy and material science, and metallurgy, materials and material science and minerals. Now, suddenly, why we are talking about this virtual lab and thinking about students? That you must be thinking about. So this idea came up when the recommendation was there in our meeting by Honorable Prime Minister. So the recommendation came that CSIR must think for the students and for the teachers of this country. So therefore, we took this initiative. We took this effort. We are taking this effort. We have not started fully. So we have started just taking this effort. So real virtual lab is to arouse curiosity for science and not for a curriculum-based content. I read this line to let you know it will not be a curriculum-based content, and there is really a challenge because already our students are very much pressurized with lot of curriculum. So on top of that, if they have to learn something new, I understand they will be under a lot of pressure. So how do you make something interesting in the way we want to talk about and that can connect their curriculum? So we are having that kind of idea. So we need your input in that regard. We will show you some of the concept, how this thing is going to happen when the concept in our CSIR R&D concept is connected, mapped with the curriculum that you have and you are teaching the students. And that then there are experiments which cannot be done, and there has to be remote experiments that is very much required, especially during this COVID pandemic. How can we do remote experiments? That has to be understood. Work out innovative pedagogy for teaching science to school students. And the concept of virtual lab will take science to the village level and attract more students towards science. This is really challenging, and we are coming up with innovative methods of doing so. I'll share with you. Develop scientific methods to develop scientific curiosity. Science teaching through games, science in art, videos, simulators, board games, quiz, etc. may be taken up on priority. So these are the recommendation of CSIR governing body, and we are working to make this thing like true. Now, the aim of the project is to encourage students to learn science with fun by creating innovative learning tools through virtual laboratory, utilizing advanced digital technology, focusing the areas of minerals, metals, materials, and metallurgy. So that is our objective. But when we are talking about advanced digital technology, we are missing out a large number of village students because many of them may not have digital technology. Although that statistics says nearly 75% people are having households are having mobile phone now, but many of the people, they do not have the smartphone. So how can we really do so? Therefore, we are also thinking about some program which is not totally digital, but some version of the program which can be done by the people, by the village people, in such a way that the knowledge can be transmitted. Now, what are the deliverables of the projects? I'm going straight to the deliverable. One is the science, activity and task. You can see activity number, that is science and maths games. And there, what we thought as a scientist, because I belong to NML, and I discussed with my colleagues here. So what kind of thing that we can do which can be suitable for 11 and 12? So mathematics to understand crystallographic structure of materials. I know standard 12 students, they study crystallographic structure of materials, their BCC structure, HCC structure, HCC structures, and how many like gaps are there, and etc. etc. They learn. So when they can draw this crystallographic structure, because it is very difficult to understand 3D structure. So how do they do it? Through maths games. We are planning on that. We are planning on mathematics for prediction of materials properties, understanding sensor signals. So many things we are planning right now. But definitely, we would like to have ideas by schools as well, school teachers, students. We would like to have, and we'll see how we can march. But this topic is not really sacrosanct. Means it is not that we have to follow this topic, but around this topic we should dealt on. So that we will see. Then the T2 activity is simulation-based experiment. What is the simulation-based experiment? That will be shown possibly by my colleague, or if I have time, I will show you. So that is called, there are 5 areas that I have jotted down. That is metallurgical furnace operation. We have many furnace in NML where we do a lot of R&D using this furnace. We get metal melted in that furnace, and where the input ores and other things are given, and we can obtain some basic metals from there, and then the metal needs to be refined. So that furnace operation, students might have learned this thing in their school, but they do not know, they have not seen it. So we can have some video or simulation. Then there is a mineral processing operation. Why materials fail? There is another concept, because we know there are a lot of failures that happens, and we design materials which should be fail-proof, which should be reliable. And then we have to understand why materials fail. So this is also very much connected to the study the students do in stress, strain, and those are the area where my colleague will be talking about. Metallurgical coal chemistry, additive manufacturing process, where 3D printing is coming. Many of the schools, they are having 3D printer now, but what is the science behind this 3D printing, that they need to know. Then science and maths comics, what we are thinking about metal casting. So we can have comic strip, where we can tell exactly various steps of metal casting. A student can learn just reading those metal comic strip. I'd be very happy if some of the teachers can contact me if they have creative students who can draw good comics, because students are very creative. So I'd be very much interested. We'd be very much interested to collaborate with teachers and students to come up with this kind of comic strips and any other item or activity that I am discussing right now. So then e-waste management, another issue that NML is very much dealing on, that is e-waste, electronic waste. We have urban recycling center, and many of our colleagues are involved in that. What is the meaning of electronic waste? We have mobile phone, we have many electronics and electrical appliances in home, and we just throw them after they have they are out of order and they are becoming useless. Then we leave them in our home in their corner. We do not know where to throw them, where to keep them. So that creates a real problem. And how this electronic waste can be utilized and the metal can be extracted from there. We do carry out research on that, and we do have a lot of technology that the way so that people can really take up this thing as industry. So we are doing this work. Then sensor is a very important aspect of our research, that is understanding sensor, how it is. So these are some of the things like animation-based short science math stories. So I'll be talking about mineral processing. We'll be talking about some of the geometry, very beautiful geometry in materials, how maths are connected to materials that we can talk about or we can show. Then there is a video. We'll be making some videos here. 8 videos I have written here. So that can be more than 8 or less than 8 also. And there is another thing that we have given in activities number T6, that is performing arts. We are thinking about utilizing drama, rap music to make sounds popular among students. But I was talking about rural area. So where if we can have music, connect music, folk music with science, then I'm sure there will be a lot of enthusiasm in that. I discussed with many teachers in Jamshedpur, or I came to know they are already using some of these methods of teaching science or any other subject to students. So I really felt very good about it. So we are going to make some music and drama for popularizing science. And another important aspect that is virtual laboratory talk by women scientists. The reason is this is a 2-minute talk on stories of women scientists about career opportunities in STEM. STEM means science, technology, engineering, and mathematics. So that is called STEM. STEM. What is happening that girls, they do not take up science, they leave science and they go to other branches, and it is very important for women to join the brigade of science. The reason is women can be very creative and they are very practical from their point of view. They think, they see in a different way, and that is very much required in science, because when there is innovation, there has to be development. So we need that perspective, and we are missing that perspective. So therefore, we would request you to really take up this issue very seriously, motivate our students to take up science, and we are going to make some video or lectures on that. And there is another thing, development of tools, devices. We are going to organize a program, means a competition for making tools, because tools is something very much useful for anything we do in our life. And many means engineering work. I'm talking about engineering work. What will happen, the students, they do not, what I have seen, that we do not like to use tool. We do things by our hand. We love to do things by our hand. Even when something has to be torn, we use our hand. We do not look for a knife, or we do not look for a scissor. And that is typically our mindset. How can we do things using tools, small tools, and that students can make those small tools by creative ideas? So we are going to have some competition on that. So what would be the workflow for development of virtual CSIR virtual platform? Like, there will be idea generation team, and this idea generation team, where schools, teachers, and students, they will be connected to that. They will feed the idea to the idea generation team, and the idea generation team will give this idea to the VL development team, that virtual laboratory development team. There will be a lot of conversion from idea to videos, idea to animation, idea to simulation, idea to comics, idea to dramatists or rap music, many things. So there will be conversion. The VL development team will be involved in doing so. And then there will be outreach and documentation team who will be involved in connecting school teachers and students. And then there will be from there the CSIR-NML virtual platform will come up. And also this outreach team, they will be interacting with CSIR-NCL, because they are our nodal agencies to take the information from us, and they will put the information after shortlisting in CSIR virtual platform. And there will be some virtual interface between CSIR-NML virtual platform and CSIR virtual platform. So there will be some interface. With that, so this is the connectivity that we are thinking about, but this might change. This is not what we have written. It will be like that. It might change. So can you hear me, all of you? I just want a little feedback. Is it okay?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Thank you so much. And then, like, the challenge is, when we are talking about virtual laboratory, what would be that physics, chemistry, maths, bio, environment science, and we are here in the middle, minerals, materials, metal, and metallurgy, that I called 4M. Now there will be various kind of level. Level 1 means standard 8 and below, and level 2 means standard 9 and 10. Level 3 means standard 11 and standard 12. Level 4 means undergraduate or postgraduate, you may say so. Like, now what kind of level we are targeting? So definitely, as I told you, that our target is from level 1, 2, and 3. We are not targeting level 4. And so it is a really challenging task to come up with something, because we are so focused in our research, in our work, because we are more concerned about 4M. Now, how do you convert this 4M to physics? How do you convert this 4M to chemistry? How do you convert this 4M to maths and the other branches of science? Today, the parallel session that will happen, that the chemistry will include all the bio and environmental science teacher, And if there is any computer science teacher, exclusively computer science teacher, they can come to the session of maths. I did not write down computer science separately. So see, this is the essentially the three branches we'll be discussing this today. That is physics, chemistry, and maths. Now, how to visualize science? That is through videos. I already told you simulation, and you can see that there is a diagram, arrow diagram, that scientists, teachers, and then students. In videos, we are creating video, students are seeing that, but we really don't know how much students in understanding, because the flow is not duplex. There is a terminology in electronics that is called duplex. Duplex, that is two-way communication. So this is videos is that single directional communication. Whereas simulation, it is a two-way communication. So where teachers and scientists, they can create a simulation structure. Then students can put data and they can see what is happening. So this is a two-way communication. Similarly, experiments, that is the experiments students do for their physics lab, chemistry lab. I don't know whether they have maths lab or not. So in that chemistry also, in that experiments also, it is a two-way communication. So one thing that we are thinking about, we are really ideating, how can we do remote access experiments, where definitely teachers can talk about that. And then there are one-way communications, means role play activity, where we can understand how much students can understand about the concept. Games, where we can understand how much students can understand. And tool making, also we can understand how what kind of concept students have in terms of doing engineering. So when they would like to make tool, they will be making tool, their concept of engineering would be understood. Now I was trying to understand what is really being taught in like in 11, 12 chemistry, not physics, not chemistry. So I'm thankful to Shuvendu. He is there. He is a science teacher. He's a very good teacher. So he shared the syllabus with me. So one thing that I've seen, to make a paper scale of given list count of 0.3 cm, 0.5 cm. Is it okay? Is there any problem?
That is okay. Your voice is fading away, but it's okay. Go ahead.
Okay. So, is there? Can you just switch off your mic if it is creating a little noise? Okay. Now, that typically the students are told to make a paper scale, so that with a list count of 0.2 centimeter, 0.5 centimeter. When they talk about, they learn the list count, they memorize list count, they write the list count in their exams paper. But when it is coming to the real world, I will just show you real world, and my colleague Dr. Shiva Prasad, he will deal with this thing in more detail. Like suppose in a specimen we do in our lab, we do experiment where we understand the tensile property of material. Tensile property means when the material will deform. There are a lot of other properties that are there, that stress strain curve. These are the things we do it in the laboratory, and we do have to do a lot of measurement. When you do measurement, we use vernier scales, vernier calipers, we use micrometer, and in the 11, 12 students are taught how to use this vernier scale. And what is the concept of least count in this vernier scale? They are taught in a very detailed manner. But when I was in class 11, it was very difficult for me to understand. I'm sure the students are much more smart now. They are quite smart now, and they can do understand better. But how can we make things very simple for them? And I would be requiring help from teacher to do these things. Like some of the example I have given, ultimately in NML, we get this kind of property. What is the tensile strength? What is the YS? So the knowledge of list count is being utilized to get the material properties. So you can understand the conversion of knowledge from the knowledge in class 11, 12, the understanding that 11, 12 that is happening, that is being implemented when they do work in R&D laboratory. There is a vernier calipers videos are there. So I'm not sharing the video, but I don't know if you will, we can share, like if you want, we can share this video later on also, because Should I share the video? Would you like to see the video? Can I have some response, or I can leave this one?
Yes, you can share the video. I'm Shubhendu.
Okay, all right. So let me share the video so that you can understand the concept of vernier calipers.
Ma'am, the audio is not coming.
Okay. Is it coming now? Is it coming now?
It's not coming properly.
No, ma'am. No, audio is not available.
All right. So I will I think all of you you know how to search a video in the net, what to see. You can definitely find out. I just wanted to give you a feelings like there are a lot of huge resources in the internet to understand various concepts. Only thing is students do not have time to understand that. So therefore understand also, like not understand, they do not give time. So therefore how to transmit knowledge quickly, how to flow knowledge quickly, so that they can understand the concept very easily. So that kind of system we have to devise, and that is a very much challenging activity, and we will be requiring your support. So one thing that came to my mind: can you use a mobile phone to carry out the same measurement? Can you do? For some of the difficult thing is there might be challenge when the shape is like in a very difficult shape to measure without a micrometer or vernier calipers. But I can tell you it is not very difficult. So students have to learn now how to use mobile device to do lot of activity, measurement activity or many other activities. They have to learn the trick. So maybe we can do that kind of sort of video, or we can make that kind of video so that the students, they learn how to do this thing. There are other videos also, like tensile testing video, how it is done. Since the audio is not coming, I'm not sharing this video. Like I just like to share a simulation video. Okay, that I would like to share, that simulation video. Let me do that so that you can understand when I talk about simulation video, what is that. This is simulation. I have to copy this thing because the link has not been created possibly. I hope that you are able to see the operation. See, this is a Steel University. They have done extensively good work. Since I was talking about tensile test, I'm going to give some example there. So in that, this is a simulation setting. One is conduct a tensile test on a test piece from a sheet plate, and you have already prepared. And I'll just show you something. See results of test on high carbon steel rod and wire. So that means we'll show this experiment, start simulation. You can see what happened in lab. We have the testing machine in the left side, and there we have this kind of data collection. So when there is a stress, the tensile, there is a tension in the wire or a rod. So definitely the load is increasing, and there is a displacement that is taking place, for which the stress is generating in the material. And there are some special devices that takes the results, that takes the value of the displacement and load, and from there stress and strain is calculated, and we get the data like that. And so you can understand like how the simulation will take place, where student will have some idea about how to change some of the parameters, how to change the material properties, and then they can like they change that data set, that pattern of data they can change. So that kind of interactive things are being done in simulation. So there is another example, beautiful example, to determine mass of a given body using a meter scale by principle of moments. I'm sure it is very easy for teachers, they can understand, but teach students, for them, even for sometime for us also, it is quite like we if we do not do work in that domain, we keep on forgetting. So when we read again, we understand that how this is a simple concept, and we have learned class 9, 10, 11, 12 student, they do this kind of thing quite. So these are some of the concept-based video, and we have to create that concept. Now, my question was like, can a DIY, do-it-yourself tool be made to do this? Whatever can be done using that fulcrum and that lever and rotation, anti-clockwise rotation, clockwise rotation, those kind of thing, and calculate the weight using the principle of moments. Can the students make a DIY tool to really calculate the weight? So these are the questions that can come. So this is essentially the end of my talk, my presentation to you. I hope that you have understood things. I could communicate. It's not you who have understood. I could communicate it well. So the focus group discussion, we'll have this focus group discussion after my talk. There will be three groups. One is physics, chemistry, and maths. I told you there are three parallel sessions. Dr. Shongita will be sharing the link for physics and chemistry. Maths group will be remaining here only, maths and computer science. And then the visualizing physics session will be chaired by Dr. Shiva Prasad, and Dr. Srima possibly will be helping Dr. Shiva. And then we'll have visualizing chemistry. Dr. Mahanti will be there. He will be the chair, and Dr. Shashwati will take care. And visualizing maths, myself, I will be there. And with me, Dr. Aniket will be there. So this is the way we plan, and we'll have a very focused discussion. And we can have a question answer session for some time, depending upon the time. At least 5 say 10 minutes we can have question answer session in this session after my talk. Then the expected outcome of this group discussion is capturing ideas, suggestions of teachers to plan a roadmap for developing contents for students. So I request all my chairperson to capture ideas of teachers, have this good discussion, and then to understand if the teachers require any kind of training or internship opportunities, so that the quality can be improved, or we can do something good for the students, for the teachers, if they have any idea or any help or guidance that is expected from NML. So we'll be very happy to offer that. So with that, I would like to thank you. Thank you, teacher. Thank you so much for listening to me. I think I did talk in uninterruptedly, and I hope that you will ask me some question so that I can understand really that you like that session, or you could I could communicate you properly. With this, I would like to thank you again.
Thank you, Dr. Meeta Tarakar. I request everyone to please follow the link in the chat box for the chemistry and physics session. And for math session, the link will remain same.
Okay. Can we have a sort of question from teachers?
Okay.
Or they can write the question in the chat box. Just quick questions, 2-3 questions I will be answering, if it is okay. Was it good? Could you hear my presentation?
Yes, your presentation was quite nice. I'm Shubhendu.
Oh, yeah, nice to see you. Okay, you could hear my presentation. Okay, any other teacher?